We're going to be focusing more on building to particular platforms. And all of your Visual Studio, have you all made Windows apps before, or Windows Phone apps, and you know all the Visual Studio side of things? Yeah. Well, basically I'm going to show the really, really difficult process of clicking a button in Unity and building a Windows Studio project. But I'll be talking about Unity-specific things, such as overwriting that project, making changes, things you may need to set up in Unity that will carry across into that end project. Then you can go wild to your heart's content with descriptions and whatever else you want to do. Yes, so our compressed agenda, so it's only one slide now, which is cool. So yeah, building Windows Store app, Windows Phone app. So we're going to take that Fruit Ninja game that we made, or that Fruit Splat game, and basically build it a Windows Store app with it, then a Windows Phone app with exactly the same game, writing no extra code to two different sort of platforms, which is quite terrifyingly quick and cool. Then in Visual Studio, we'll be setting up the project, how to overwrite that project, so you don't have to build your game, then think, oh, okay, I want to build more of it, or change something, or I forgot to type in a variable, things like that. Then go back and then building a second project, and then that doesn't work, and then building a third project, and then eventually at the end of the day of development, you have like 60 individual Visual Studio projects. I'll show you basically how to not do that and only overwrite the Unity files of the Visual Studio project, which is really useful. Then I'll talk about intro to mobile development. So those who used Unity before, have you done any mobile development like touch events or swiping, or so there's like two people nodding, the professionals are nodding, that's cool. Okay, so we'll be going over that. So talk about touching, raycast touch, tilting, a couple of bits and pieces. Then, if we go on to sending an event method from Unity Visual Studio, so what we'll do is we'll create a static class in Unity with an event listener or event handler. Then, when a particular event happens in our game, we'll then on the Visual Studio end of things, basically edit the C# and make the phone vibrate when we do something in the game. So it's kind of like going that bridge of carrying Unity stuff over, or some form of function, and calling a function over, and then accessing a particular property of the device in that event. So basically you're bridging the gap between Unity side of things and the device side of things. And that'll be like a example of how you can do that, and then there's a couple of other ways that you can do that, but I'm sure that we could sit here and talk all week about all the other things that you could do. Cool. Then if we get onto it, so yeah, this is a bit ambitious like yesterday, but we got through yesterday, so yeah, I have high hopes. Get onto native 2D tools, animation system and animation state machines, which all sound very terrifying, but they're very straightforward and smooth, and we'll have like a little sprite sheet of a character running, and then push a button, he'll be punching, and then go back to his running animation, and with like a couple of lines of script, which is quite straightforward. But yeah, awesome. So, if I then have a blue screen of death, nope, okay, cool. So yeah, so I'm running Parallels to run Windows 8, so it made it so I'm technically running two OSs. So yeah, pardon?
Nothing bad will happen.
Well, if you're my Mac, then cool. So does everyone make sure that their game still works? So I know some of you are working on it and implementing. Who implemented Christmas presents and candy canes? Yeah. That was pretty awesome. And other people put in like a split, so you hit a lime and then it splits into two other limes. That's so cool. Like, that's pretty awesome. I didn't do any homework. Sorry, teacher. Yeah. But we know that it works and it's all fine. So what we're going to do with this is we're going to build to two different platforms. One's a touchscreen device and one's Windows Store app. Without writing any extra code. So what happens is that the input that we have, so for example the clicking input, when you build it to a touchscreen device, it basically detects that click as a tap in quite a primitive method of taking in that touch input. So what I'll do is we'll build it this way, then I'll talk about more specific touch input type methods and how to then split up sections of code. So this bit only executes if you're doing it to, for example, a standalone build, and this it only executes if you're doing it to a touchscreen device. Groovy. So what we're going to do is we're going to go to File. Actually, we're going to import some files. So if you go to that mobile build resources folder and open it up, that .zip, So this is when I find out someone who hasn't got the assets and wasn't listening earlier on. You'll find 3 files. So one of them in there is a texture of a laser. One of them's a package called Spaceship Zipped. So like where we had the fruits package yesterday, it's exactly the same thing. It's a big bundle of a whole load of fun stuff, which you can just open. Other one is a bunch of icons. So in the icons folder, there's 2 sets that we're going to be using. So one's Windows App Store icons. So why can I not preview it? Okay, take my word for it. Basically, it's all different variations of sizes of fruit on a plate. So what we're going to do is in Unity, we're going to assign these things into the particular columns. Then when we build our project, it's going to carry those images over. So when our tile on the Windows like splash screen, Windows 8 splash screen, basically you can resize the tile and it's swapping in and out different images based on that, which a lot of you already know how to do, I'm guessing, in Visual Studio. But you can set it up in Unity as well. You can set it up either side, basically. What we also have, in Windows Phone icons, we also have an image of a spaceship, which you're going to be using and applying to all different sizes for the build to the Windows Phone. And basically that image is big, so then it will resize down and scale very nicely. So yeah, it's kind of 2 different types of images that we'll be using. So if you grab your 3 files, so icons, packages, and textures, select them all, and then add them into our project. In this case, I'm going to copy them. Cool. No Trojans, don't worry. Yes, so the assets folder of your project, the Fruit Splat project, like when we've imported everything else, just take those 3 files from the mobile build resources and just stick them in there. So in Unity, you should now have Fruit Splat, which has our Fruit Splat game, icons, packages, scenes, sprites, standard assets, texture, and toast spawner. Everyone okay with that? Not too difficult yet, right? Yeah, the bad jokes are coming out already. Wicked. So what you'll notice is that if you open up the icons folder, and then open up the Windows App Store icons, we've got a series of icons. So we have Fruit app icon, we've got a Fruit logo, we've got a small logo, a wide logo, we even have a splash. So what we can do in Unity when we export our project into different platforms is basically do platform-specific settings. So, for example, if we're building it to a Windows Store app, we can assign these different size logos and these different images all within Unity, so we can include everything in our build, send it over the other side, and then build it the other side. You can still do the Visual Studio end of things, so what we're going to do for the Windows App Store side of things is do the image setting up in Unity, whereas with the Windows Phone, we're going to do it in Visual Studio, which you guys already know how to do. So you can see that you can do it either ends of the scale. There's a couple of other things you have set up. So for example, your device is in portrait, landscape, if it auto-rotates, all these different bits and pieces. So yeah, we'll do all those. So we've got these icons, and we've got a texture folder, which has like a little laser fire button. We're not going to use that for a bit. And in our packages, we also have a spaceship, but we're not going to open that for a bit. So we have our game, and it runs very beautifully. We click the green line, and we have some form of explosion. You might have sparks, you might have Christmas presents. It doesn't really matter, as long as you have some form of interactivity that you can see. So here is the magic list. So if you go to File, Build Settings, you'll get a panel that looks just like this. So this is kind of like the end point of Unity. So you brought all your assets into Unity. You've created up your game, or you've created up your visualization of some form of content or media or whatever it may be. In NASA's terms, Mars, which is quite cool. And then this is basically the list of what you want to build to. So this list expands and extends when new build platforms are integrated into the engine, or you have specific engines. So for example, Xbox One, you'll have a custom version of Unity which builds to Xbox One, which then sits alongside your normal version of Unity, which is available to everyone. Whereas in this case, this is kind of like all the things that have been exposed. So obviously we have Web Player, PC, Mac, and Linux Standalone, iOS, Android. We have all these settings. We have these two here, Windows Store Apps and Windows Phone 8. So what we need to do is we need to change this logo, because the logo basically says what we're currently targeting. So in this case, the default for any project when you make it is PC, Mac, and Linux standalone. It automatically targets that one. So what we need to do is we need to say we don't want to target that anymore. And what you'll notice at the top of the window is it says, it has basically a rundown of our game. So it's got what program we're using, so Unity, the scene we're opened, the project, and then PC, Mac, and Linux standalone. It's basically showing like a construct of what we're actually viewing. So in this case, we're targeting PC, Mac, and Linux. Now what we need to do is we need to switch that. So if you select Windows Store Apps and then click Switch Platform at the bottom, basically what's going to happen is the logo is now going to sort of reload a couple of assets and handle things. And it's basically going to swap that little icon to that one. So now we're targeting a Windows Store App platform. This way we can then open up sort of the engine a bit more for that particular platform. So for example, if we were going to build to let's say a Wii, if you switched it to the Wii, you'd then be able to access Wii controller and things like that. It's kind of like a way of switching to these different platforms, and it's very quick in accessing specific things. So we have Windows Store Apps, and we've set it at that. We can see Windows Store Apps at the top right-hand corner. Next thing that we need to do is we need to add some scenes, because this is basically going to include all the scenes that we have in our game. So if you had like a menu screen scene, and then like a main game, and then game over, and high scoreboard, and social links and things like that, what you need to do is you need to bring these scenes into this drop-down list and order them how you want them to load into the game. So obviously you're going to want your menu to load in first, then later on when you finish your game, then you can load in the rest of your bits and pieces. Basically it's just a drop-down list. We only really have one scene, so what we can do is we can either click the Add Current Scene to add Fruit Splat, or just drag and drop Fruit Splat into this list. So we now have this scene of Fruit Splat in here. So that's going to be in the build. So one thing that a lot of people do if they've started using Unity is they don't include any scene, and then they build it, and then they just have a blue screen on the other end, and then they complain their game's broken, things like that. And it's simply because they just didn't add it into the build process, which is fine. So now that we've got that, we then have specific things. So what we need to do is we basically, if we want to debug this and basically do some bits and pieces on the other end, we need to change it down to XAML C# solution. So choose that drop-down list, then choose the SDK. So in this case, I'm building to Windows 8.1. So are you, who's on 8.1, who's on 8.0? You all on 8.1? Hopefully. 8.1. 1. Okay, that's cool. So what basically, you obviously know what your current Windows version is. So I'm on 8.1, so I'm going to build to 8.1. Then before we click these two buttons, we need to click Player Settings. So we've currently set up a couple of bits and pieces, and now we go to the Player Settings. So what the inspector will do is it will pop in to a bit more information that we can fill out. So if you're in a company, so in your case Microsoft, or if you're your own indie company or studio, whatever it may be, you basically type into the company name, which will then basically go along with your packaged app to wherever it goes to. Because the way that Unity works in this build window is whatever target you select and whatever you build to, it basically compiles like a native library for that specific target. So in Windows Store Apps and Windows Phone 8 case, it basically builds a Visual Studio project with, in this case, a C# solution, so on and so forth. It basically builds that for you. And what you can do here is, rather than for each platform you're building to, so for example, a lot of people build to all the mobile platforms so they can get it on as many devices as possible. Rather than filling in iOS company, Windows Store Apps company, Windows Phone 8 company and things, what you can do in the player settings is basically say, my company name is, in my case, Unity Technologies. That would then go embedded with any platform that you build to. Next is the product name. So if you built a PC, Mac, and Linux standalone, so either of those platforms, the little application icon that gets installed onto your machine would don this product name. And if you build like a Windows Store Apps or Windows Phone 8 project, it will then don that product name as the project name. So in this case, I'm going to take out the space in Fruit Splat and leave the product name as, Fruit Space Splat. Now when we do our spaceship game, we're going to change that to Space Blaster or Spaceship Shooter, whatever you guys fancy. But yeah, so Unity Technologies, Fruit Splat. So who out of you has just put Unity Technologies? Normally one person does because they're still waking up, so yeah, that's a good sign. Cool. The next bit underneath here, so we don't need to worry about default icons, default cursor for what we're doing. Next thing that we need to do down here is this list. So this list is basically this list here, but sideways, horizontal. So with this list, we basically pop into which particular platform and do more specific things. So if you're building a web build and you open up that one with the globe, what you can do is you can open up, you can say the web player template is black, white, what screen size it is, specific things to that platform. But we're not targeting that. We're going to target Windows Store apps and Windows Phone. So let's go Windows Store apps. So what you notice underneath here is resolution and presentation doesn't have anything. For example, Windows Store apps are more of a desktop app like so. Whereas if we went to Windows Phone, you'd have things like default orientation. Is it a portrait game? Is it landscape? Does it auto-rotate and things like that? So in this case, we don't. Next thing is icon, not applicable on this platform. Splash image. These are kind of all placeholders for all the platforms across the grid, so some of them are deactivated for certain things. If we go into other settings, we can set a couple of things. So for example, do we want dynamic batching to happen? How frequently do we want the accelerometer? Do we want to disable the accelerometer? In this case, we don't. Let's not disable it. Next thing is publish settings. So if you open up the publish settings window, this is kind of like the bit that we want to be looking at. So here we have package name. So this is basically how it's going to be bundled. So in this case, I'm going to take out that space and call it Fruit Splat. It then dons the package display name. So a lot of these bits and pieces we're setting up here, we can do in the Visual Studio side of things. But I thought, as you guys already know about, I thought I'd show you stuff you guys may not necessarily have looked at before. Next, we have version number. Publisher display name just dons whatever your company name is. Next thing here is logo. So this is kind of like the mini icon that you're going to have that's going to go next to your app. So what we want to do here is we want to click the select option. Mine's going to think about it. Navigate to your icons folder. Windows App Store icons, and it's the one that's 50 by 50, so which is no. Oh yeah, cool. So yeah, so obviously 50 by 50. Unity even tells you what logo size it's looking for. If you do something slightly different, like a slightly different size, I don't think Visual Studio likes it on the other end because you're passing in like a 600 by 600 image into a 50 by 50 thing, and it gets a bit funny with that. So if you double click that and select it, it basically will then do a lookup to your icon. Now you need to include your icon in your project folder, because if you have this icons folder elsewhere sitting on your downloads folder or documents folder or whatever, you don't include in that build on the other end, Visual Studio will basically say image missing, or this particular text that it's trying to find is not there. Next thing we can do is display name and description. So description we can fill in on the other end when we actually have a bigger text field box. The next thing is setting up the tiles. So what we can do is we can basically sign up all these tiles and it will swap them in and out depending on what size. So if you then go into your icons and set them all up, so for example I mean it's fairly self-explanatory really. So the wide tile with the wide tile, small tile with the small tile. Yep, set those things up. You have the short name, in this case Fruit Splat. So if you have a really long name, so for example, the guys who made Lego Star Wars Yoda Chronicles, perhaps they don't want Lego Star Wars Yoda Chronicles on their tile name for their short name. Maybe they abbreviate it to Yoda Chronicles or Lego Star Wars or whatever it may be. In this case, we've got a very short name, so you don't have to worry about that. Set whether we want to show names. So these are all kind of just fairly self-explanatory bits and pieces that you set up. Foreground text, again that depends on your sort of logo and what icon you're using. Background color, so that's basically going to be the border around your app. So if I go into here and, not that one. So what you can see here is we have, I don't have any installed, that's a good example. So what we're going to do, okay, so here's one that I built the other day. So what we're going to do here is it's going to take the icon and it's basically going to give a border around the outside. So it's kind of like icon mode like this, where you have your white PNG and then basically it does the background around it. I should have really put like just like a white piece of orange. I'm not sure. But yeah, never mind. So let's go back to here. So background color, consider what we want. So I'm not too keen on sort of like the pure color black sitting on top of fruit. That doesn't really seem to go with it. And as we're clicking limes, I'm going to set it to a nice sort of lime green. Well, that looks dark green on the screen, but it's lime green on mine. The next thing is the splash screen. So if you don't include the splash screen, Unity will be very kind and put their own splash screen in for you, saying powered by Unity. So basically, yeah, you can either change it or you can leave it as it is. In this case, just use the splash screen.
Don't you get it always the Unity one with a free license?
Pardon?
If you have a free license,
I think
get it all the time.
if you have the free license, it pops up your splash screen and then it pops up the Unity one very quickly, or vice versa. I think if you have Unity Pro, it doesn't do that. I know it does do that if you're doing it to a device and you have free version. So if you have the free version Unity and you build to a device, it will pop up the Unity powered by Unity splash screen as opposed to your own custom one. But that's simply because, I mean, all platforms that you build to a Unity in the free version does that anyway. But it pops up for literally like 5 seconds, so I wouldn't worry about it. Then the next thing here is overwrite background color. So you know when you open up your app, so if I go into my window and then I opened up, IE, basically this background image around the splash screen is what color that's going to set to. So if you don't like it to be pure black, go away now. Okay, cool. So I'm going to overwrite the background color, and perhaps I think that's a little too harsh on the eyes with that green, so I'm going to basically darken a little bit. I don't want to blind the user. Okay, so what else do we have? So we have a couple of other bits and pieces of capabilities, but some of them, I'm not sure if the webcam works yet, maybe? Some of these being worked on and things like that, but we can access all these on the other side in Visual Studio. So now that we have those bits and pieces set up, we're pretty happy with it. We have all the lookups for all the PNGs and things like that. What you can do is you can go to File, Build Settings, and we have two options here, Build and Run. So it depends which Unity developer you ask, but I opt not to build and run, because what build and run does is it basically generates your then native program or your native project or solution or whatever it may be, then it quickly installs it. And then it basically starts opening these things and then installing these things and so on and so forth. I'm the type that would like to build it, then make sure everything's fine, then run it on the other end. I don't like lots of things opening up in all sorts of places and then, yeah. So what we're going to do is we're going to build it. So we click Build. Then what Unity will do when you click Build is it will basically navigate it to your root folder for your project. So in this case, for the assets, library, project settings, and temp. So what I'm going to do is I'm going to make a new folder, and this is going to be called WinStore Apps. Go into that folder, and then I'm going to make another folder, and this one's going to be called Fruit Splat, not Flat Fruit. Let's build one. So the moment that you do select folder, it will then start building it. So make sure you have a brand new folder, which is all fine for that. It will then use that folder you selected as the root for when it builds the project. So I'm going to click select. It will then build it. So it depends on how big your project is, what you've got in it, what you're building to, and things like that. This isn't a particularly big project, so we'll be fine. What you may see happen is in the game view, will basically swap between the different views. So if you have like 20 scenes, it will then swap into like a blue screen, then it will basically might swap in the other scenes. It's literally just taking all your assets, everything that you've got in there, and then creating some form of thing in your target device, which is then readable on the other end. It's kind of like packaging it up, putting a bow on it, and then shipping it off to what you want to do with it and whatever platform. So in Xbox One's case, building a Visual Studio project, which will then go to Xbox Ones and so on and so forth. And I call this the cup of tea loading bar, because every time I build something, I go make a cup of tea and come back, and then it's done, and then I have a cup of tea as well. And if it doesn't build, then yeah, I don't get a cup of tea. So yeah. One option that's in here now is cancel. Don't click cancel, or you just have to rebuild it again. So that's basically a way of, say like we built halfway, and funnily enough I still do this, and then I realize, oh actually I haven't included any scenes, so I'm now building a completely blank project which just has a file size, it has literally nothing. You can click cancel, it'll basically stop the build, and then you'll be able to go back and then add your scene in and then rebuild it and things like that. So what will happen when it's done is it will close that build settings, and it will navigate to wherever you built your project. So this is for anything that you export from Unity. It will basically navigate to your particular project. I think someone's just built it and it works all fine, right?
Yeah.
That is a good sign. So what we're going to do is we're going to open up that folder, and this is probably a bit more familiar territory for you guys. And what will happen is it's compiled a Visual Studio project. So you have your solution here. Inside Fruit Splat, we've basically got all of our assets, all the different bits and pieces, our main page, our project. We have this file called data, which I'll talk about in a sec. But what I want you to do is I want you to open up the solution, and I think it'll, well, we'll see. Either automatically open it in Windows, in Visual Studio for Windows Phone, Windows Store in this case, or it'll throw up like a version picker, and it will say which one do you want to. Oh, in this case, it's automatically done it. So mine's thinking about opening it. Opening it up, doing its business. Preparing. So this is another cup of tea. So by this time, you've got a lot of caffeine. Okay, beautiful. So we've opened up our solution. We can see in the right-hand side here, we've got all of our solution items. So some of these items, so for example, if we go into the assets folder, what's happened is it's basically taken over, it's basically taken things like the store logo, the square tile, the splash screen, the small tile, and things like that. And it's kind of renamed them just for like our project, and it's basically carried over those icons over. If we go down and we open up the data file, this is the thing that's interchangeable. This is basically the variable in this project now. So if we said, let's build it first, and then let's do the thing second. So what we can do is, if we open up the package .appx manifest, so yeah, this one. So again, this is probably all very familiar for you guys. We can basically tweak a couple of things that were originally in Unity, but a couple of extra things as well. So in this case, description, it's just donned on the name of Fruit Splat. So we can say something like, no, come splat some fruit. Awesome. Available on the store now. I don't know, something like that. So then you type in your description. A couple of things like entry points, like .app, you don't want to play around with. Supported rotations. This is if you have like one of those funky screens that like flips round and things like that. Has anyone got one of those screens here? I saw one around, but okay, no one. Then we've got a couple of toast capable things, so notifications. So currently in Unity, I don't think there's a native like built-in thing to do toasts and things like that. So you know, like it pops up with a particular notification. But I think they're working on it. I'm not too sure. I think there's a couple of plugins on the asset store, like Prime31 tends to be the guy who makes all like the plugins and third-party bits and pieces to access native stuff on devices and build platforms. But if we keep scrolling down, we'll find. So if you go to Visual Assets, what you'll notice as you scroll down, it's basically taken in that icon we set up in Unity and it's dragged it across. So if you didn't like the Unity way of having things and already having your tile in there, you could just go in and just populate the assets folder yourself and then drag and drop bits and pieces in there. I mean, this is all familiar territory for you guys, so yeah, you can pick and choose whichever way you want to do. You can set default size. It's all very standard. But basically, it just shows that the Unity end of thing it's adopted a lot of sort of things that we've set up on this end. So now that we have all these, what we need to do is we need to switch so it defaults to ARM. We need to switch from ARM because we're not targeting that sort of processor. We want to switch it to whichever. So in my case, x86. then build to local machine. So it'll then build the project to the local machine, and it should open it up. It's basically going to say build started, and yeah, I'm kind of preaching to the choir. What should happen is things like the splash screen will pop up, and the background that we set for the splash screen, and icons and things like that will pop up, and our game will be running all in Unity. You got an error? What does the error say? Oh, cool. So my thing's popped up. This very beautiful plate of fruit, lulling people in false sense of security what the game's about. Are you doing a debug build?
No.
You're doing a master? Okay, so who's got some fruit?
So you need to build those separately.
Okay, so if you do a debug build, basically everything like the audio and things like that is kind of a bit choppier because it's a quicker build.
Release version, and still like cannot. It's just random.
Bizarre.
Yeah.
Okay,
On this one.
click escape and go back.
Okay. So. Is it a touch offset?
Change the, release, okay,
What's the issue?
bizarre. It's only registering the click sometimes.
I heard that there is a workaround for that because there's some touchscreen and so on facing disturbance.
Okay.
Do something I read about in the Unity forum somewhere
Right.
because I heard about this issue.
Okay,
But that's usually just touch though. Yeah. It's kind of strange.
bizarre. Okay, and that's a release version that you're making, right? Not a debug, because I know the sound gets a bit choppy in the sound and inputs and stuff like that gets a bit choppy on the debug version. Hang on.
Yeah, but it's really interesting because I deploy exact same thing to the Windows Phone and there it registers everything that's going wrong.
Interesting. Right, I'll try a release version and see if it's... Yeah, mine's... So my debug version's better than my release version. It does sometimes register, but not directly, yeah. Okay. Right, let me have a look. Does yours work? Sometimes.
It's taking its sweet time.
Oh, not.
Is this normal or?
This computer has some iffy issues. Oh no, it's really.
The shop is sounding.
Because we took the GUI text, kind of anchored it in the top left-hand corner, it's now resized to whatever size. So if it's a free aspect, it's top left. Portrait, it's always going to sit in the top left-hand corner of whichever view we choose. So in this case, I'm going to build it landscape. So then go back to File and then Build Settings. So we have this window again. So we're very happy with how that's turned out. Go into Player Settings and we have default orientation. So portrait is up. Landscape right was if we went from portrait and then we went right. Landscape left is went from portrait and then went left. Obviously, we could have the phone upside down, but that doesn't make any sense, right? Can anyone think of any upside down games where you hold the device like that as opposed to, I don't know. Or we could set it to auto-rotate round. In this case, we want it to be a landscape left because we're having the device and then turning it left. Icon and splash image are available on this platform. And underneath other settings, basically, it's not available as well. So what we're going to do now is build it. So instead of clicking build a run, we're just going to build it like normal. Instead of under Windows Store Apps folder, we're going to make a brand new folder and call this Win Phone Apps. And there, make a folder again and call this Fruit Splat Phone Build. 1. And then build it. So what this will do is it will basically build another Visual Studio project separate to the other one, but specifically for Windows Phone 8. So when you open it up, it will be under Visual Studio for Windows Phone as opposed to Visual Studio for Windows Store Apps. So we have two different versions of Windows Visual Studio running. Cool, so we've made our cup of tea, our thing's been built. We can open up Fruit Splat Phone Build 1. It's created almost exactly the same file structure, yeah, basically, as our previous Fruit Splat. So if you open up the solution, it's going to say to me which thing do you want to open it up. Open it up in Windows Phone and click OK.
I got an IO exception. Temp stat staging area assembly C# already exists.
Okay. Oh, my product will expire in 3 days. So we've got our build there. I mean, some pretty epic music for a fruit picking game. So it's building to it, but we've got a couple of sort of performance issues and things like the audio being choppy in certain versions, like the debug version, things like that. But it's still clicking and it's still a built thing on your device. So what I'm going to do, and I know there's a couple of problems, but I guess getting how many, like 30 odd people to build all to different devices from different machines is always going to be an interesting time. Yeah. So what I'm going to do now is I'm going to show very quickly and very easily on what if we wanted to modify this project. So say like we've built our Fruit Ninja game or Fruit Splat game, whatever it may be, and then we think, actually, I want to do some more Unity side of things. I want to add more objects. I want to basically continue developing my game. What would I have to do? Would I then need to build a separate project or not? Well, you wouldn't need to do an iterative build. So, for example, have build 1, build 2, build 3, build 4, build 5, and by the end of, like, you know, a couple of builds, you've got 50 different versions of your project. You're not quite sure what's in each one. So what we can do is we can build over the top of this project here, and what that Unity does is it goes in and it swaps out the data and the resources files, which is all the Unity stuff. So all the Unity end of things in what it builds and things like that is just in that data folder. So it holds all the other things. So we don't need to build a new project, go in, fill in a new description, reassign app icons, do all this stuff, build, then do the same thing over and over again. So make sure that you don't have your Visual Studio like playing and debugging on the device. So for example, if there's a little stop button in the corner here, click stop, because you won't be able to overwrite this file whilst it's currently running on your phone. You're going to have to click stop. So it should look very blank like this. So if we pop into Unity and let's make some form of alteration to our game. So I think the background looks a bit too dark and miserable for this sort of thing. So I'm going to select the main camera. I'm going to click the background icon and the background color picker. And I'm basically going to make it so it's green. So it's got a bit more life to it, I guess. Some of you have already added like textures to the backgrounds. Some of you, I think. Textures. In that case, just change something like turn one of the fruits and make it bigger or something like that. Just so something that's a noticeable change. And obviously with our background being green, we can't see our text. So if we just select the text and change it to something, dark grey seems to work. So we have some form of noticeable change. It doesn't matter what the change is, but it's a different, it's a different version of our game. So now what we need to do on the Unity end is basically go File and Build Settings. click build, and then all we do is we don't build a second project here. We just select the root of that other one, so Fruits Phone Build 1, select the folder, and basically what Unity will do is it will go through and it will replace all the Unity things inside that Visual Studio project. It won't change anything else, all the Visual Studio side of things. It just only changes those things which it needs to change, basically. This normally takes less time than when you build it for the first time, because it's not doing a brand new build from scratch. So after that's done, and you've got a thing built, go into Visual Studio, and there won't be any noticeable differences. No flags get popped up to say, oh, your project has changed, so on and so forth. And all we can do is we can rebuild to our device, and our thing will be different. It's swapped out for that newer version of the Unity build. And we don't have to change any logos or icons or anything. So yeah, you don't need to reopen Visual Studio or anything like that, resave it. It updates that data file automatically. Now I'm going to build and see what happens. So yeah, I've now got a green display, looks very pretty. That was very quick, no problems. That's really hurting my eyes now. Cool, awesome. And oh, this is the little stop button I'm on about. So if I now try to rebuild, so I'll show for example, if I go into here and then go, okay, I'm going to rebuild over that file whilst Visual Studio is still running the game. So click there and then click select folder. What Unity will do is it will go to a point and then some error will pop up saying temp file already exists or something like that, and it doesn't like that. So yeah, there we go. So yeah, temp, staging area assembly and things like that. So all we need to do is we need to just go into Visual Studio, stop our game, then we can build over the top of it because it doesn't like swapping out that temp file, but it's a very minor thing. Does that make sense? Has everyone managed to do that? Make some form of change in the game and then rebuild over the other version? It's actually pretty quick. Awesome, cool. So, apart from a couple of issues, we've managed to build 2 projects. Awesome. So with the code that we wrote for detecting the touch input, what it does when it builds it over to like a handheld device, which necessarily doesn't have a mouse input, is it almost does fake touch input, which is a weird way of thinking. What it does is it says, okay, we recognize that you're trying to detect a mouse click, and it kind of then swaps out your code, so instead of a mouse click, it now detects a touch event of you touching the screen at a particular location. Now that might be why it's a little bit choppy in some cases, and that's something I'm going to have to research and then send an email to all of you about why it's doing that. It's something I'm going to have to look into, but I can't quite do that right now. But relying on, for example, that fake code to come in doesn't allow you to access other purely native touch events and touch functions and things like that, which is what we're going to do now. We're going to build a mobile game from the ground up as opposed to one which we built to 2 platforms using the same block of code. So let's do that. So if we go into Unity, we're going to still work in exactly the same project, but we're going to tidy up a couple of bits and pieces about it. So what I want you to do is to go alongside all of our other folders, I want you to go to create a brand new folder, and this one's going to be called Space Blaster. So inside Space Blaster, I want you to drag packages and texture. So yeah, packages into Space Blaster and texture. So you should now have Space Blaster folder, packages and texture. So inside texture, we have a very pretty button icon of like a blaster. We're going to use this to detect where we are touching on the screen, and if we touch on the screen, we're going to say, is that touch within that particular touch area? So this is where I was saying my surname a lot, by the way, which, yeah, gets a bit strange. So yeah, we've got that button there. And what we need to do now is open up the packages folder, and we should have Spaceship zipped. And like we did with the fruit package, which we unzipped and had lots of prefabs and lots of fun bits and pieces, we just do exactly the same thing. So if you double click that, decompress the package, we've got a whole bunch of fun stuff, and import all of that in. Cool. So it's basically distributed some of the folders out amongst your basically your whole project root. So we're going to move a couple into Space Blaster. So I'm going to move the Simple Particle Pack into the Space Blaster folder, Space Fighter Scene into the Space Blaster folder, and that's it. So inside the Space Blaster folder, we have Packages folder. It keeps that original package if you wanted to use it in a different project or re-download all the assets again. Simple Particle Pack, Space Fighter Scene, and we have our texture. We have those 4 things. Simples. So if we open up Space Fighter Scene and open up Scenes, we should have a scene called Space Shooter Scene. So we need to double click that and open it up. And yes, we want to say Fruit Splat. So we now should have a spaceship. Everyone okay with that? Awesome. So I'm going to talk about a couple of things that are in these folders. Some of this stuff you won't need to touch, but it's probably good that I'll point that out, what we've actually imported into our scene. So if we open up the Simple Particle Pack, basically what we have supplied is textures and materials and flames, things that's used in a particle system I've put on the ship for its boosters. We don't need to really sort of go through and poke around with those things. Then, if we go into the Space Fighter Scene, this is kind of where all the important stuff is. So we have our Scenes folder, which has the Space Shooter Scene. We've also got a laser. So if you go into the laser prefabs, we should have a laser which has a little tail on it when we move into the scene. So if I drag and drop a laser into the scene, what you'll notice is that it's basically moving around like that. So that is a component which you can add to any game object that you want, called the trail renderer. So what the trail renderer does is as an object moves, either with physics or by code or any forms of movement with it, you can give it some form of little trail which will trickle behind it, and you'll be able to specify things like time, like how long this trail exists in the game world, its start width, its end width, so you could have it like as a pointy tail and things. So we could go into that Fruit Ninja game and have like the limes have like a little green trail or things like that. So this is kind of like a fun way of doing lasers, and if I move it around the scene I can see how this trail goes. So it starts off as light blue, and eventually it fades to dark blue over time, which you can see. So where's the laser? Oh, and the laser's got a script on it as well to make it travel. So what you can see is it's basically, yeah, it's traveling along as well. So we're going to do a couple of things, like we're going to tap a button and fire a laser, which is pretty awesome. So we have our spaceship as well. So if we open up the spaceship, if we select the spaceship in our hierarchy, what you'll notice is that there's a mesh renderer, it has an animator, but we're not doing animations to it. It has a rigid body as well, because we're going to be moving the spaceship using force, as opposed to very rigid movements. We're basically going to say, if our finger is swiped to the right, swipe to the left, or we tilt the device to the right, tilt it to the left, we're going to basically apply force in that particular direction, so we can see it moving around. Then if you open up that parent object, I've childed a couple of things to it. So the process of childing objects to one another is basically to say, this child now moves in relation, or scales in relation, or rotates in relation to this top object. So it's very easy to child an object to another thing. So if I go in and I make a cube, like so, very simple, and I want to, for example, attach a sphere to a particular face of the cube, and I want to move the cube, and that sphere is then a child of it. So what you can do is we can then create our sphere, like so, position it into location, and what you'll notice is that the child and the sphere are kind of separate in this hierarchy, though both are children of the entire scene. However, if I take this, so if I move the cube, it's basically going to move independently, and the child doesn't, and the sphere doesn't move with it. So if I take the sphere and I drag and drop it onto the cube, just like we drag and drop a script onto an object and things like that to make it a component, what we'll notice is the cube now has a drop-down list, just like as if it's a folder. and we'll be able to open it up, and we then have the sphere like so. And if I select the cube, basically the sphere is now going to move in relation to the cube. So then if I take the sphere, we can move the sphere around, do all sorts of funky things with the sphere, and it will basically move on its own accord, ignoring the cube. However, if we select the cube and then move things and so on and so forth, and rotate things like so, basically now the sphere is basically going to move where the cube is. So this is particularly useful for building up a big scene, because what you can do is, say like you've got a forest of 10 trees, rather than moving each tree individually, you could put all those as a child of empty game object and use that as kind of like an empty file or like a holder, and then move that parent object and moves all these things around. So if we have a look at the ship, which is like so, what I've done is I've childed to the ship 3 things. I've childed an empty spawn point, which is sitting at the nose of the ship. So this is where our laser is going to fire. So if we view the ship from behind, basically, the laser will fire and move out forwards. And I've also attached 2 particle systems, which are basically going to act as like the little boosters of the ship. So it's a bit more of a visual niceness to it, I guess. So what you'll notice is that if I select the ship and I move that around, basically the boosters and the spawn point are all going to move along with it. I don't have to write extra code to say you are now moving in relation to this particular object. You can drag and drop it within the hierarchy and say you are now, for example, a child of the spaceship. So it's a useful way of managing lots and lots of objects in your scene rather than having a massive list of everything. Cool. So we're going to write some code. So inside our Space Blaster folder, I want you to go to Create and C# script. And under C# script, I want to call this spaceship control. Also in the Space Blaster scene, I want you to create another folder and call this scripts. So Space Blaster scene, the Space Blaster folder should now have packages, scripts, all the other things. We now have spaceship control to sit inside that script there. This is going to control all the touch inputs for our game in relation for a spaceship and apply something to it, such as force or fire a laser and things like that. Then if we take that class, or that script, and attach it onto the spaceship. So we now have a spaceship with script waiting for us to tell it to do fun things. And then double click that script and open it up. Okay, cool. So I'm going to use MonoDevelop for this bit because I don't have Sublime installed on Windows, installed on my Windows partition. But yeah, so we have our script works there. Cool. So what we did beforehand to do some form of input for the mouse is we wrote something. So this is just kind of like just an example. We had input.mouse position. So whenever we clicked, it basically got wherever the mouse was on the screen and sent a raycast out, which was fine because it converted those controls. And even though we had a couple of optimization issues and things like that, it was still detecting a click. It was still detecting a tap on our devices. What we want to do is we want to write some code that's specific more for touch inputs. So if I go over to my... So the differences between desktop mobile development and Unity, these are the 4 main things. So one's input controls. Obviously, you're not going to be able to tilt your Mac and then it will like translate over to your device. You're going to have to write some extra bits and pieces for that. There's extra SDKs. So if you want to access more specific things to your device, you're going to have to use these SDKs or use these links and things like that. Obviously, devices. So I put that in terms, that's quite a broad term, but I put that in relation to different device sizes, device types, different hardware. Some devices will be able to hold a lot more things drawn on screen as opposed to other devices. And optimization is another major thing. I'm not going to specifically go into optimization, but if we have enough time I will, but we might be pushed for time. But optimizing, there's all sorts of little neat tips and tricks, and I've got a couple of projects and slides and links to things. So if you are interested in doing some really hardcore optimization for mobile devices, just give me your email and I'll just send you all my content over that I normally talk about and stuff. But yeah, those tend to be the four main differences. Other than that, all your assets and things can moderately stay the same. There's a couple of things you may want to do, such as level of detail. So you don't want a super hyper-realistic spaceship, for example, that looks beautiful and has all these light shaders and textures and things in your project, and then try and push it to the device, because it's going to have too many things that Unity can't render or things like that. It's going to spend most of your rendering power on this one spaceship as opposed to all your scene. So you may want to do a level of detail and basically swap out that ship for a different version. Like Grand Theft Auto does this. When you're flying a plane, everything's kind of like billboards and flat images, and then when you get within a certain distance, it all snaps into a 3D object. It's basically swapping those things out. And it's very noticeable in those games, which is quite, yeah, suspicious. Like, but that's fine. So let's do some touching. Okay, so the first one is touch.position. So the way that it works in Unity terms is touching the bottom left-hand corner of the screen is 0, 0. So this is any rotation. So if your device is like this, and you touch down here, it should be 0, 0. That is your origin point, and 0, 0 in X and Y. However, if I did it like this, so it's portrait, basically tapping the bottom left is 0, 0. It basically rotates to whichever way it works around. So obviously if I tap there, it will be some number that's not 0, 0, and it works from that particular area. If we just do a touch area, it's one method of doing this is to basically have some form of GUI text or some form of thing on the screen. Then if I tap there, it will basically do a hit detection test saying, is it currently tapping this particular object? If it isn't, then fine. If it is tapping it, then run some for a function based on that particular thing. We're going to do all this, but I thought I'd go through it all first. So you could have multiple laser buttons and all of those blast different bits and pieces. So we have touch phases. So touch phases are a way of detecting how your touch is recognized. So this is kind of like, you know, we did that input.key down and then get key up and then get key held and things like that. Touch phases are kind of the same thing. So you have a touch phase began. So that basically means when your finger comes into contact with the screen, you can do some form of thing. Touch phase moved. So that basically means your finger is moving around on the screen, something is happening. Touch phase stationary. So your finger is on the screen, but it's currently being held on the screen. And touch phase ended, which means it's been released. There's another one called touch phase cancelled. So for example, you're in the middle of a touch phase and then you're at quits or closes or a phone call happens or something like that. So touch phase cancelled, it may go back to a pause screen or something like that. That's another thing you can call. So the best example of combining all of these different touch phases is Angry Birds, funny enough. And it's the one that all of you know. There's one guy who says, I don't know what Angry Birds is. And yeah, you've come to Finland, the home of Angry Birds. And yeah. So, for example, the touch phase began in Angry Birds would lock the bird to wherever your finger is. It's basically say, we are now in slingshot mode. Then touch phase moved and stationary would then work out where your finger is in relation to the slingshot, moving the bird around. Then when it's ended, that's when it's released. So you're basically combining and cycling through all these different phases to say, it's now at the release stage, now release the bird based on your power or how far your finger is from another point on the screen. So let's do some setting up some touch phase environment. So, like I was saying, oh, can you guys see that or not at all? Or it's a bit difficult. Let's make it bigger. Cool. Okay, I don't want to do that.
Not that old. Now, if you press Control and scroll, yeah.
Okay, that's no bigger. What? It's lying to me. I don't want to zoom in on parallels. That'll make my life. How's that? Is that a bit better? Beautiful. Cool. So, like I was saying the other day, there's many different ways to cut the cheese or cut the quiche or whatever the saying is. It depends where you're from. And doing touch phases can be handled in lots of different ways. So the one way I particularly do is to kind of stop cheaters. I don't really like people who cheat in games, so especially when they cheat and they have infinite health in a game and I can't kill them, and then that's super annoying when I'm playing competitively. So one thing that I do is I always detect at the start of every update loop how many fingers have they got on the screen, because then you can monitor this. So if you're doing this finger touch, the fruit game, obviously people are going to cheat and they're going to get their friends, then you have 20 different fingers and they'll be able to get a ridiculous high score or something like that. So one thing I always do for whenever I do any touch phases to work out how many fingers are on screen and then limit that. So if it is a Angry Birds style tap the screen and drag it, I perhaps only want to use one finger. I don't want them to be able to add another finger, and then you have all sorts of variables that come into play. Maybe you do want multiple fingers. So the first thing that we're going to do is if there's only one finger on the screen, do a particular event. Then when we get to a stage where we want to fire from a button and swipe at the same time, then we'll open it up and say if it's greater than no fingers on screen, then do this, but it's less than 3 fingers, for example. So basically I'm going to show you how I do this particular collection of fingers and touches and stuff. So what I do to begin with is I make a private integer and call this finger count. So this is just simply to store how many fingers are on screen. It's very, very simple. Then the next thing I do, and this is probably the strangest line variable I will ever create in any form of program, is do private touch, first touch, partly for the implied and the fact my surname's in it twice. So yeah, it'd be a bit embarrassing if I misspelt it. Private touch, cool. Okay, so what we're going to do is we're going to find out how many fingers are on screen. Then if there's one finger on screen, we're then going to take that finger and basically pass all the information about that finger, so what its position is, if it's moving, or its touch phase and things like that, into the touch variable. Because this touch variable basically stores all that information. So you know when we had the raycast, we had that raycast hit, which was returning what we were pointing at. So pointing at the projector, it returns where the projector is and what it looks like. Touch is kind of the same thing. It's like this nugget, it's like this gold mine of information about that particular touch phase. So if we go into void update, I'm going to get rid of that so no one's confused, which is cool. At the start of the loop, I'm basically going to say finger count equals input.getTouch. Oh, sorry, I wrote the wrong line. Input.touchCount. So we're basically returning how many fingers on screen. It's basically input. The input manager is then saying, or the input class is saying, this is the number of fingers on screen. I could have just left it as input.touchCount, but then kind of that gets a bit messy, just running input.touchCount everywhere. So I always like to sort of narrow things down and cache them for later on. So every frame, it's going to say how many fingers are on screen. Then we can do our stopping of the cheaters. We can then say if finger count equals 1, then do all this business. So if we didn't do something like this, so I was taking part in a game jam, and we were doing like a single screen multiplayer game. So what you had is you had one player firing a crossbow, and the other player was like an item. You had to dodge the crossbow. It's quite strange. It was a game jam, okay? It was a very strange game. So we came to a debate about this. And he was like, oh, I don't see the point of finding out how many fingers are on the screen. Let's just write it the whole game. I was like, okay, we'll do it your way. We did it, and then everyone was cheating in the game and getting their friends to fire multiple crossbows and things. So I was like, well, if we built this in from the start, we wouldn't have this problem. And yeah, and then he realized the issue. So, but then he probably tells a completely different story that he was right the whole time. Yeah, but we're both British, well, so we're very polite about these sort of things. Cool, so what we're going to do now is if there's one finger on the screen, because input.touchCount is basically detecting constantly there are 0 fingers, now there's 1, now there's 2, now there's 3, now there's 4, so on and so forth. And depending on your device is how many fingers it can basically take in, and how many fingers it can detect on the screen. So what we're going to do is if there's one finger on the screen, we're going to basically say first touch equals input.getTouch 0. So this input class is basically storing how many fingers are on screen into an array. So the first finger is this 0 item in the array, which when you explain it to someone who doesn't know what an array is, it's quite difficult to, yeah, surely, yeah, they get a bit tricky with that. Now that we have our first touch and we have this little gold mine saved, we can then do our touch phases. So what we're going to do is we're going to say if first touch dot phase, first touch dot phase equals touch phase dot began. So we're going to do it first with an if class, well, in an if statement. Then later on we're going to use a case to cycle through all the different types of touch phases that we're using. So it's kind of like showing you different ways to do this. So if first touch dot phase is touch phase began, so we're not detecting where we're tapping on the screen. We're doing something like Jetpack Joyo. You can tap anywhere on the screen and it will perform the thing. We're then going to go and run the function fire laser. There you go. We've written the simplest touch input that you can possibly do. So outside of update, we want to write this function called fire laser. So void fire laser. This is going to be a very simple thing. And say game objects. So I'm currently writing in a couple of variables which we're going to set up in a sec, but I'll write that whole line of code and then add these things afterwards. I'll put these on extra lines, don't I? Cool, so we've got a very simple instantiate. Now, you know what I say about the whole clone extension on the end? So basically I'm then going to say created laser dot name equals laser. Cool. So when we do like a little vibrate through the phone, so what we're going to do is later on tap it. We're then going to send this message to like an event handler or listener on the other end of the built project in Visual Studio, and then access the vibration of the phone. So every time you fire a laser, it's going to vibrate the phone slightly, which is pretty cool. So we have that bridge working. We haven't put these variables in yet. I was just going to write that whole. Not yet, not until we go into Unity. And then it will get angry. Cool, so what I'm going to do now is I'm going to add in the laser prefab and the laser spawn point objects very quickly. And we're going to expose those in the editor. We're basically going to make them public so we can attach objects to them. So this bit is kind of like stuff we've already done yesterday. So I guess it's revision? Don't know. So why is that got there? Oh yeah, I did as well. Okay, not bad. Rookie mistake, eh? Yeah, cool. Thank you. Cool, so we have our touch stuff sorted. Awesome. So, has everyone got that written down? So with that sorted, what I want you to do is go back into Unity, make sure there's no errors, then attach the spawn point that's on the front of the spaceship into that slot, and go to the laser prefab in your folder and basically attach that as well into the laser slot. So like what we did with the fruit and the spawn points and the cubes and the spawn points and the toast and things yesterday. I'll do that as well. Okay, cool. So we have our laser. Cool, laser and spawn point. And we have our very simple touch input sorted. Cool, has everyone got that all set up? They got the script written down. I can show you the code again if you want. So now that we have these two public variables at the top, just go into Unity, select the spaceship, and we're assigning the laser prefab, which is in your folder, in your project folder under like laser prefabs, and also the spawn point, which is at the front end of the ship, which is actually like floating just in front of it. Empty game object. I'm using an empty game object again as like a spawn position. So one thing you'll notice is if you now run this in the editor, nothing will work. The spaceship will sit there, motionless, sitting there, has its little boosters running, but if you tap the screen, it won't work. Although I haven't tested it on like a touch screen, I don't think it works. Interesting. Okay, so I guess the touch screen takes mouse input as opposed to pure touch input. Yeah. Okay, cool. That's simply because we haven't built it to the device. So on other mobile platforms, there's a thing called a Unity remote you can download. So with the Unity remote, what you can do is you can basically hook your phone up. If you go to the same Wi-Fi point that your machine's on, so kind of like they're both at the same point, what you can do is you can basically, when you run the game in the editor, it almost sends the feed out to here and you can use it to test inputs and touch things like that. Remote like that doesn't exist yet for Windows Phone. I think it's in development, but I can always double check with that. It probably is in development. We do have like some dedicated Windows Phone development team, and they're probably working on some form of alternative for that. So what we're going to have to do is we're going to have to build the project, but luckily it doesn't take that long to build it and overwrite the other file. It's not like Xcode, which takes ages sometimes. So now that we have our game in, we can run, if we run our game, we can still use the boosters as kind of like a thing to make sure our game's all running, it's not crashing, there's no errors running and things like that. We have our touch input scripts on. So what we can do now is we can go to File, Build Settings. Now, there's a couple of things we need to change. So currently we're all set up to build our Fruit Splat project. So normally in a proper game development scenario, you'd have sort of your project for Fruit Splat and your project for the Spaceship Blaster. But in this case, we're operating it from the same file. So what we need to do is we need to add the current scene that we have. So what that will do is clicking Add Current will take the scene that we already have open, add that to our build stack. And what you'll notice is that scenes of fruitsplat.unity will always load first, whatever's at the top, so whatever's in that 0 slot. What you can do is we can just toggle that off. So we say, we don't want you to load, we want this one to load instead. Or you can alternatively drop it above the other one. So yeah, so make sure you have Space Blaster active, nothing else active as well. We want that one to be the scene that we see. Now before building it, what we're going to have to do is we're going to have to change a couple of settings. So if you go into player settings, what you'll notice is it will say, we are now going to build the product with the name Fruit Splat. This is quite obviously no fruit. This is a spaceship. So we're going to call this Space Blaster or Laser Shooter, whatever takes your fancy. We're also going to go down to resolution and presentation. So we're going to leave it a landscape left because we want the game to sit very kindly in our hands like this as opposed to like this. We want it to be this sort of game. So landscape left. And then once we're all very happy with that, we're going to click Build. Now, instead of building it to the Fruit Splat phone build one, because that will just overwrite those files, we're instead going to make a brand new file in this position and call this Space Blaster build 1. And select the folder and build it. So it's just now going to compile the Visual Studio project, all the bits and pieces, package the Unity stuff very nicely, and push it all into here. Cool, so once it's done, open up Spacebar build, open up the solution. Well, you'll notice the solution's names won't be FruitSplat anymore because we changed its product name. It's basically swapped it out. Open up Visual Studio for Windows Phone. And I prepared a very nice, very pretty icon to basically attach onto it.
So where do you attach the script? Where do you attach the script? Oh, so maybe you keep it on the spaceship. Oh, anywhere.
Okay, one thing that we are going to do in a sec, so now that we're building to the phone and test that that actually works, is we're going to use a thing called define. So do you guys who are like Unity, do you use defines or use a define in your code to define what you're building to? And yeah. So what defines do is they allow you to, instead of writing a script, exactly copy and pasting the script and having one script for PC or mouse or things like that, one script for touch inputs, one script for Xbox controller or things like that. What you can do is you can do it all in one script. Use a define to say, if we're building it to, or we're currently running this in, for example, a standalone build, a Windows Store app, then use this block of inputs, use this block of code, use this block of script. However, if we're instead building it to Windows Phone, use this block instead. So what we're going to do is, now that we have our... Has everyone else got lasers? Or no? Oh, you go. So, tapping anywhere on the screen and lasers are happening. So it could be quite not as smooth workflow having to then go back into Unity, change some things, build to the device, check it, go back to Unity, build some things, change the device, so on and so forth. So what you could do is you use define in your code to basically say, if we're building to this platform or if we're testing in the editor or things like this, then target the editor or swap out the controls. So what we could do is we could say, instead of tapping the screen to fire a laser to test it, we could say, if we click the mouse button, then that replicates and runs the bit of code for fire laser because it's in the editor. It will make more sense when I write it, don't worry. Because currently, if we run that in the editor, clicking or tapping, it doesn't fire any lasers, it doesn't do anything. I don't have a touchscreen device and things like that. So what we can do is, if we open up the code, we can use a platform define to basically say, block out this bit of code for this bit of code, and so on and so forth. And it's very, very easy to use a define. So the way that you can do this is basically, it kind of looks like an if statement, but worded slightly differently. So use a hashtag, which is, I don't seem to have, oh, there we go, okay. So yeah, define, oh, it actually goes if. Then we basically say what version we want to basically include in this. So we want to write Unity editor. So we're going to be running this in the Unity editor. Then we need to end it. So we basically then get the hashtag and then we go end if. So yeah, basically we can then wrap that around some code that we want to execute if we're running the game in Unity Editor. So in this example, we're going to write if input.get key down mouse 0. Actually, it didn't have a space yesterday, so then we can say, yeah, fire laser. So if we click the mouse, then it will fire the laser. Then we can wrap this other section in another if statement, basically to say if it's actually a Windows 8 build, execute this touchscreen code. Cool, so hopefully that makes sense. It basically then says, oh, we're using Unity Editor. Now, on the Unity 4 script reference, it's basically got a massive list of all the platforms that you can do this for. So Unity Editor is if it's running the editor. I mean, there's standalone builds. If you're doing it to Windows Phone 8, it would say Unity _ Windows Phone 8. If you wanted to do it to, for example, Metro, it would be something like Unity _ that's the equivalent of Windows Store apps. That's what you would put instead. And basically, yeah, you can couple that all up. And
in your for if it's if Unity with WP8, it also do or and.
What? Or and of the if statement?
Yeah.
Yeah, so you could go, for example, and then that basically, yeah, and then go something like that, yeah. So you can say all these things which have touchscreen devices and things like that, then click this. So a known third-party plugin that's widely used, which doesn't necessarily work on Windows Phone yet, and you have to tweak it, is NGUI. So has anyone here heard of NGUI? Or so basically, NGUI is like a third-party plugin which is made by a guy called Michael, who basically has written his own GUI system for Unity, and then he sold it on the asset store so people can purchase it, and it's kind of like his own custom GUI package, and everyone basically uses it. But one thing happened was that the Windows Phone was released, but he didn't update the package because he was working on our own GUI system, so we kind of like hired him to make our own GUI system. So he's working on our system. Then when Windows Phone and Windows platforms were released, his GUI system, which is used by tons and tons of developers, wasn't working or wasn't compatible with Windows Phone, Windows 8, and so on and so forth. So the very, very quick fix to do that is to literally go to a specific line of code, and this is on all the forums and stuff. It's like line 629. I remember because I had to fix it so many on the porting day that do this, but I think he's done an update now which does support it. And basically there are so many ones which said like Unity _iOS, Unity Android, so on and so forth, Unity BlackBerry, and all I needed to do was go in and go, and it fixed it, and basically it allowed to have NGUI on the system. Yeah, it was just simply as adding Windows Phone _8 to that particular build target. So yeah, you can do like ORs to say if it's this or this or this. Cool. I think a maximum you'd only really have like one for mouse and keyboard and things that are on the desktop, one for handheld devices, and then one for like maybe an Xbox controller or console devices and things like that. Cool. So now if we save that. Pardon? I got that wrong yesterday as well. Yeah. I should have learned. So now if we're in our editor, we have some errors. Oh, okay, yeah, sorry, I forgot bracket. So now we can basically replicate touch controls and just say click on this particular bit. I know it's not specifically to it, and you're going to have to sort of almost like right mouse input controls that replicate a touch, but you can, for example, test it in the editor, then build it, and it would then work on here. So yeah, defines are pretty useful for not having to duplicate the amount of scripts that you have and keeping everything in one place in the same script, which is useful. Awesome. So now that we've got that if in there, we're going to work a bit more on the touchscreen stuff. So it's 11:36. So something like if device dot touch. I don't, off the top of my head, no. But on runtime, you can detect what application is currently running. So you can say if application.runtime equals Windows Phone, for example, then you can run a particular thing based on the if statement, or you can use this system. But I don't think, there probably is a way. Yeah, yeah. This is true. Off the top of my head, no, but I'd be surprised if there wasn't something like that. I've got to look into it, and then I'll get back to you. But there's probably something.
Another thing that you said that we talked today about how to export stuff from Unity to Visual Studio Code from Codemount. But how about the other ones?
You can do that. We'll get onto that later if we have time. Yeah. I'll talk about that a bit later when we do the bridge stuff. Yeah. Cool. So we're going to do more code. So currently we've got it tapping anywhere on the screen and then fires a laser. That's okay if we're doing something like Jetpack Joyride, where it's like a single touch game. But what we want to do is we want to restrict our touch to a particular button in the bottom left-hand corner. So we're going to use GUI texture. So like we had GUI text to a label in the top left-hand corner, we can use GUI texture to put a little text in the bottom left-hand corner. Then when we tap the screen, do like a hit test to say if the touch has began and it's hitting this particular GUI, then fire the laser. So it's basically detecting if you're tapping within these coordinates. So what we do is go to our project, go to our texture, and we have our texture like so. Looks very pretty. So if we go to texture type and open that up, we've got all the different types of textures that we can import this to. So like when we had a 3D model, we basically generated colliders or imported blend shapes and basically do all those things. And like with the audio, we toggled it between 2 and 3D. You can do the same thing with the textures here. So in this case, we're going to change it from a texture, which would normally be mapped onto like an object, to a GUI. And we're going to click apply as well. So basically, it's now going to prep the image to be rendered as a GUI on the camera layer, on top of all the things in the scene. So if we go to game object at the top and go to create other GUI texture, what it will do is it will automatically make it will use a lovely Unity watermark, and it will make a game object on the side, and it will have a GUI texture component on it. So I'm just going to rename this as laser button, and I'm going to swap out the Unity watermark small for that texture. So I'm just going to drag and drop the texture into that texture slot. So we now have, we've got rid of the watermark, we now have that fire laser button. Cool. So obviously that's a little bit squished, so we're going to have to resize it. So I'm going to set its width to be perhaps 150, its height to be 150, its pixel inset to be -75 and -75. So obviously that's going to sit in the center of the screen, but it's basically offset it to the left and down a bit. So if I want it sitting in the bottom left-hand corner, and I set its, remember the position is basically proportionate, so it works from 0 to 1, 0 to 1, so I set it to be 0 and 0. It's going to be sitting a bit like that, which I'm not too happy with. So I'm going to go to the pixel offset and set it to be 0 and 0. So it's now anchored to the bottom left-hand corner here, and then it's basically drawing this texture like so. That may be a little bit big. But most of the time with GUI textures, you'd have to build it to the device to basically see how big it is in relation. So for example, a tablet, it might be fine if there's a tiny little button in the corner, whereas on a handheld device, you might need to like shrink it down. So I'm probably actually going to say 150 is a bit extreme. Let's go 100 by 100. And then if you really want to, you can then change the color to be like red lasers. I think we've got blue lasers, so I'm going to change it to blue or light blue. And we have our little GUI texture being rendered on top of everything in the scene on its own overlay.
What did you do to get it in the corner?
In the corner?
Yeah.
Okay, so with the position at the top, it defaults to 0.5 and 0.5. And the way that the positions work for the GUI text is it starts at 0 here, and then 1 to the far right-hand side, and 0 at the bottom and 1 to the top. So it's more like a percentage out of 100 as opposed to like a whole number. So I just set it to be 0, 0, then took out the pixel inset, so rather than it being positioned there, it's kind of like anchored there. Cool. So I want it to sit in the corner in ideal thumb space. Okay, cool. So has everyone got that little picture in there? So what we're going to do is we're going to do a very simple hit test. So if we go into our script, what we can do is we can say underneath here, we can then set up another variable. So in this case, GUI texture laser button. Set that up there. And what we can do is a number of things. So we could nest another if statement inside this touch. So we can say if the touch phase has began, then if that touch phase began, if it clicks this button or the pause button or things like that, then execute a particular thing. Or we could do an or statement to say if the touch has began, no, instead of or I mean and, if the touch phase began and the touch is in the same sort of area as this and it's a hit test, then fire the laser. So whichever way, you guys are pretty smart, so whichever way you want to do it, that's cool. I'm just going to use the and method. Oh, okay, that's obviously not and. So I'm going to say if first touch phase has began and laser button dot hit test. So we're doing hit test against that variable we're going to cache. Current touch dot position. So you'll see something fairly familiar in that current touch dot position. Why is that not? Oh, first touch. Sorry, my bad. So remember when we did the mouse input, we did input dot mouse position. Now we've got first touch dot position. So basically, it's kind of similar. So input, so the mouse position when we clicked, it would basically get the position where it was on the screen and fire a laser to that in that general direction to that point. Whereas in this case, what we're doing is we're accessing that little gold mine of all these touch things about all this touch information. And we're saying, go to that gold mine and get the position. So like with a raycast, when it returns hitting an object, it's saying hit.point for its point that it hits, hit.name, hit.collider.gameObject.name to get the name of the object. We're basically accessing that little pool of data and getting exactly what we want. So yeah. We can say if touch screen began, and we do a hit test to make sure it touches the button, then for our laser. And basically that will automatically say if touches began and it's not hitting the button, then don't fire a laser. So we've actually restricted it down to this button, or this particular GUI texture.
How can I get the mouse position in Unity editor if I want to add the same condition in the first if?
You'd,
0 and hit test input dot mouse position. Test there, what okay, into the mouse position.
Okay, I've just written that off the top of my head, so I'll have to test if that works. Oh, it doesn't like that. I'll probably put something wrong somewhere. Oh yeah, keep doing that. Oh yeah, okay, so another thing that we have to do before we can test that this works is to select our ship. And now that we have that GUI texture that we're doing the hit test against, we basically need to store it. So drag and drop the laser button into that GUI texture slot. So we should have laser, spawn point, and laser button, and then you can test it. So if I tap anywhere else on the screen, but if we tap that little section there, it goes pew pew. So if I go back to my code, yeah, so basically we've kind of written the same thing twice. So we basically said if input.getMouse down, which is basically the same as saying if there is a finger down. Then we do a hit test to get the position of the mouse against the GUI texture, and we're doing the same thing here. So you can see a similar pattern emerging. It's not two completely vast languages. They sort of are, like for example, touchscreens and mouse, they are sort of merging together. So we can test our stuff in the editor, but with a little trickery. So once that's done, try building it to your phone and see if that is the right size for your thumb. Everyone's got different size thumbs. Mine are quite wide. So yeah. Oh, that works. That's cool. Okay, that's awesome. So what we're going to do now is we have 8 minutes. Is it? So we have a couple of minutes. So let's do some tilting. So we're going to implement some tilting into it. So what we're going to be able to do is tilt the device, and the ship's going to move left and right, and we're able to fire missiles as well as it moving left and right. Now that seems like a lot of stuff to implement in 7 minutes. But tilting is funnily enough, one of the easiest things you can possibly do. Like, it's less code than detecting your first touch on the device. It's super straightforward and easy. So, if we go back into here, obviously we can't put any tilting code into the Unity editor, because if I pick up my, yeah, that's not going to work, for example, unless I had, you know, some form of accelerometer built into it, which I don't think it is, but yeah. So what we're going to do is inside the if Unity underscore Windows 8, so in this particular area, we're going to put a tilt function. So after we have the finger count, because we don't need to detect how many fingers that we have on screen to detect the tilt, instead we're going to write some code which gets what the tilt is. So the way the tilt works is on a vector 3. It works out which direction it's being tilted and by what the value is. And it depends how you're holding the device. So in this case, it's kind of a bit trial and error sometimes. So the best example I can have is if I have the device like so, if I was to tilt it around the y-axis, it would be like that. So if I was doing something like doodle jump, so I wanted to tilt that way, basically that would start at 0, and then as I move that way, it would move slowly towards -1, and it would move slowly towards 1. So those of you who've done like joystick inputs and stuff, it's kind of a similar way of doing it. So that's around y. Now, if I was to tilt it sideways and do it around that, so I tilt it that way, that would be around x, whereas that way would be around z. And it's kind of a weird way of how it works, but the best thing to do is just write the code and then test it and see how your game feels. Like, does it feel better tilting it like that or like that, and so on and so forth. So let's do that. Let's make some cool tilting in this. So if we go back to our script, we have to write a couple of things that we're going to cache at the beginning. So the first thing that we have to do, and this is going to be the most important thing, is to make a vector 3 for the tilt vector, and we're going to start it off at tilt vector 3.0. So when the app runs and initializes, and when it reaches this particular variable, it's basically going to say start at 0, so all values at 0, 0, 0. If you don't do that, if I start the app running it like that, it will be slightly different for when I rotate it around and do it that. So it's going to start off at 0, 0, 0, which is cool. Another thing that we need to do is, let's do a simple little display. So this little display is just going to simply show how our device is currently being tilted. So let's do a simple GUI text saying tilt display. 4 minutes, no pressure. So that's simply so we can put it in, so we can debug it and basically say, okay, we can see the X value getting bigger, the X value getting smaller. It's probably X that we need to rotate it around. Then, underneath all this touch input business, we then write the most complex line of code ever to exist in Unity to get what the tilt vector is. Tilt vector equals input dot acceleration. There you go. How difficult was that? Did hear someone go, whoa? That will basically get the accelerometer of the device and work out which way it's being tilted or how it's being held in that particular way. Then, just so that we can see what it's doing, we can say tilt display, so that text that we're going to create in a second, equals tilt vector. Or, if we want to be really specific, we can do a really long string just so that we can see what it looks like.
Can you scroll up? No, down. A little bit more. Oh.
Like that. Okay. So basically I'm now going to split up all of the tilt vectors just to see what is being tilted and things like that. Super tricky. So actually this might be a good point to stop for lunch, because what we can do is we can then build it to our device, and then whilst you're eating lunch, do more work? No. Basically then test your device to see which way you want to tilt it. So do you want to tilt it this way to move the ship, or this way, and so on and so forth. So we actually have something, and it's food for thought, I guess. It's a terrible, yeah, the jokes don't stop. Yeah. Food for thought. Whilst eating food, you can have a think about how your tilt is going to work. Cool. So now we go back into Unity. We now have our tilt display GUI text. So all I want you to do is go to game object, create other GUI text, and so we have a little bit of text there. I want you to lock its position to 0 and 1, so it's in the top left-hand corner of the screen. GUI text, because we're just putting out to some text rather than like something that's a bit visual. So I'm just going to set up Cool, so we have our GUI text in the corner. We might want to change the font if we really want to be very specific about this, but it doesn't matter too much. And now that we have that there, and we have that GUI text just to show what the display is, if you select the ship and then drag and drop that text into that little text slot, you can then see on the device how it's being tilted. And I'll select the text to show you what basically my settings were to set it up in the top left-hand corner.
Cool, so there's only got the code down.